Right, so what you're looking at here is called Wavicle. We call it internally a PFX2 for a while, but the official name is Wavicle. And it's a brand new system, CRYENGINE V was under development for the last year or so. So right here we have the particle editor. On this side we have the Explorer with all the effects that in your build. Each one of the effects now is actually a file. It can be stored anywhere in the build.
So anywhere in the directory, we can actually store one of these PFX
yeah,
files.
exactly. So it's not limited to a particular directory in your build. Now it can actually be located where you need them the most.
Nice.
And here on this side we have the actual editor itself. So you see that there seems to be some sort of a node editor. It's kind of like a node editor. Each node is a component. The component corresponds to some sort of a layer.
It's like a container.
Exactly, it's a container of particles which behave the same way. And each component has a list of features. The features describe how this component is supposed to behave, how each particle in this component is supposed to behave.
And what about the color coding of these features? What does this represent? Is this based on a category, or is it based on the
right?
type?
So exactly. So the features comes in the categories. So there's several categories, and inside of each category you have multiple features. So the features are color coded based on the category where they come from.
Okay.
For example, spawn features are reds, render are these greenish, appearance are this green, etc.
Okay.
And so and then in this side you have the properties. So each feature has multiple properties that you can edit here, or can edit all the properties at once.
Ooh, that's a lot.
Yeah. And down here we have the curve editor, which we're going to take a look in detail soon.
Okay. So regarding these components, maybe we can look at the two that actually exist right here. And then I'm curious about these top buttons on top of the component. There's a checkbox, there's an I, and an S.
Right, okay, so let's go for that. So right here we have this fire effect. Some of you might have recognized it from the schematic tutorial. So this is how this fire effect has been set up. So there's two components, right? So here on top we have the tick means that this particular component is active. So if I want to deactivate the component, I can just click it, and that component gets deactivated.
Okay.
Right? Or you can click it again and activate it again. So as you can see, there's two layers to this already. So there's this fire, and then this glow. Right. So only the fire and only the glow.
Gotcha.
Right.
Okay.
So this icon here, the eye icon, means visibility. So it can hide a particular component. So as you can see, I can hide the fire effect. The difference between hiding and activating a component is activating actually deactivates the component completely.
Okay.
Particles stop emitting, and particles stop updating and rendering, of course. While visibility means that the component is not visible, but the particles are still being simulated. It's still creating a particle, it's still simulating the particles, you just cannot see them.
So it's specifically rendering, and as I take it, like you said, the particles are still being generated. If you were able to see it as it stood, you would see all these dots being generated, but there would be no sprites rendering in this case.
That is correct. Yes. Exactly. Here we have this S. This S means solo. So it allows you to isolate visually a component. It's important for or is useful when you have really complex effects and have many components.
I can imagine if you have 20 components sitting there and you wanted to actually dial down.
Exactly. So it allows you to identify what each component is doing.
Okay, that makes sense. Yeah. So it's kind of like debugging at that point.
Yeah, solo is very important for debugging. That's correct. Right, so I was looking at this effect, and I figured maybe it could make it a little bit better. So that's what I'm going to do now. See what I can do with it.
Okay.
I had an idea to create some embers, like a cartoon style embers.
So you mean the sparks that pop up from the fire?
Exactly, but
Okay.
more cartoon style, not so much realistic. I think we can do something here.
Okay.
So let's create a new component. So now I have a nice white square.
Right. And you just right clicked inside of the graph there to actually pull that up?
That's correct. So these are some of the templates that we have.
Mm-hmm.
I just picked the default. I will start with the default.
Okay.
It's just a very simple white square, and from there now I can start doing everything in one.
Okay.
So let's just get a bit closer to this. I'm actually going to
So
hide these other components.
these are multiple white squares, correct? Or is it just one white square
This
that...
is just one white square for now.
Okay.
Now what I'm going to do is first I'm going to change the size. It's a bit big. So,
A little bit more manageable.
yeah, exactly. So now I'm going to add a new feature, the location feature, circle. Some radius to this.
So the width of the circle. And now it's generating around the edge of it.
Exactly. So now the particle goes around this circle. But change here the rate. So I'm going to spot more particles per second.
Okay.
So now you can see the actual circle.
Gotcha.
So now the new particles are spawning around the circle.
So I imagine if it's a curve, it's just generating around that curve of the circle itself. Okay.
Yeah, on the perimeter. Right. So now we see that the particles are just popping in and out as they appear.
As they generate, they're basically spawning and then they're dying at some point.
Exactly. So you see that they just appear, disappear. We can improve that by going here to size, to the fill size. So it just changed the size of the particles, but now we're going to look at here the modifier. So we can choose a curve.
Okay. And this is the curve that you were talking about earlier, the curve editor, I believe.
So this is the curve editor down here.
Okay.
Right. So the way this works is horizontally you have the lifetime of the particle.
Okay.
Vertically you have a multiplier on the size. So for example, if I take this key down here and add a new one here.
And you just double click to create the key there?
Exactly.
Okay.
Right. Now you can see that when the particles don't just pop in and out. Now they grow up and then shrink before they die.
It gives some kind of random generation to it.
It's not really random. It's motion. It gives them motion.
I see. Yeah, it does give them motion. I guess in the sense of the random, I was thinking more how they spawn. So it's varied.
Yeah.
They're not all spawning at the same time. It appears to me as a layperson that it's kind of random.
Right. So they appear randomly around the circle, but then they have this motion up and down. Now we're going to play around a bit with the modifiers and randomness. This is going to be fun. So, for example, here radius. One thing about modifiers is that they don't just need to modify basic fields of the particle, like size or opacity. You can most of the attributes that you find in Wavicle are actually modifiable. So, for example, radius is also modifiable, so that can add a curve to there. Gotcha. Now, it's using the particle age, which doesn't really make sense for a radius. Change instead to random.
Gotcha.
So now I'm going to edit the curve. Right, so this white dot is the tangent.
Okay.
Based on Bezier.
All right.
Without weights for performance reasons. So the curve always go through the dots, and the white dots control the slope.
The slope of it.
Yeah.
Can you actually make a linear curve where it's just a hard edge? Is that it's not always Bezier?
Well, you can do that with Bezier. For example, you can select these two dots and to make a linear, I make this. I
There
use
you
the actual.
That makes sense.
Yeah.
I was curious about that.
Yes. Right. So what's going on here is now the domain, instead of being a particle age, now it's random. So every time a new particle is born, we'll pick a random point on the horizontal axis, and then on the vertical axis, the curve on the vertical axis is going to be a multiplier of the radius.
Okay.
So as you can see, with this modifier now, the particles will tend to spawn more towards the center of the circle than on the line around
Okay.
it. So without the modifier, you have all the particles spawn. Actually, we're going to add more particles.
Goes back to just like it was before. So the higher the slope, the less likely they will spawn.
Well, it don't actually control the probabilities directly. Is more the curve defines the probability in this case. So there's a random point selected horizontally, and then the value vertically. It's the multiplier of the radius.
Okay.
Right. Right. Now the particles are still very static. I want to make them move a little bit. So what I'm going to do next, I'm going to add velocity count.
Okay.
So as you can see now, I'm starting to compose my effects. So now I'm adding some motion to the particles, and it's based on the thing the thing about the Wavicle is that it's all based on composition. So all of these features combine with each other to create complex effects.
And in the sorting of this, like we have location circle and velocity, if you were to shift that, I believe you can shift them, correct? By, yes, just moving up and down.
Yes.
This sort order actually influences the end product, or the end result.
It can. Most of the times it might not.
And I can see how the composition is, we mentioned we're doing embers, but just thinking out of the box, you could do bubbles in the same type of effect. This would be a similar setup if you were to create bubbles floating up to the surface.
Yes, it does look like bubbles right now. That's it. But we're going to solve that.
Okay.
So next up, I'm going to add one of the coolest features that I like the most here in physics. So motion physics is a feature. It's the feature that actually makes particles move, and you can add gravity. You can add drag.
And what exactly is drag? Because people are familiar with gravity, but drag is
air resistance.
The air resistance.
So it simulates like particles being in air instead of being in a vacuum.
Okay.
So if I add drag to these particles, well, there's wind at this level as well. So I can actually disable wind. Right. So as you can see, particles are, when they spawn, they move fast, and then they start to slow down. It's because they are being affected by drag.
This is like when you stick your hand outside of a car window and whatnot. If it's flat, it's pointed straight, but if you push it upward, there's the air resistance. A similar effect.
Yeah, that's a similar effect, yes. Exactly. So now we have here the effectors. So particles are affected by global forces on a level like gravity and the wind, like you just said, we just saw. But you can also add the more complex forces, and which creates interesting motions in the particles. So what I'm going to add here is something called turbulence. I'm going to add mode Simplex curl. So what Simplex curl is? So before we had the Brownian in the old particle system, it just adds some jittery motion to the particles.
It's still quite uniform though.
Yeah, it's very uniform and kind of random, actually, which simulates like a object floating in water, for example.
Mm-hmm.
That's what Brownian motion means. But what we have right now is Simplex curl, which tries to simulate turbulence, some sort of structured turbulence, like a wind turbulence.
And this turbulence here, is this inherited by particles that are near each other, or is this strictly on a per instance basis? So what I say is, if one particle, how exactly is the fluent influence carried out from particle to particle? Can they be in groups and move, or?
Right. So the cool thing about the simplex curl is that it looks like that. It looks like it is smooth particle hydrodynamics.
Mm-hmm.
Uh, but it is a much simpler version of that. So the particles are actually still independent.
Okay.
They don't affect each other, but it looks like as that's the case.
I guess performance-wise, this is more performant. Like if we had an actual object that was going through and influencing the air, that would be very expensive. And in this case, you're able to get quite varied effects at a cheaper cost.
That is correct. Yes.
Okay,
Exactly. That's the main advantage of using simplex curl.
gotcha.
So we need to tweak the values a little bit here, a bit of rate. So it actually changes the structure over time a little bit.
Mm-hmm.
So I'm going to make it a bit faster just to see better. That yeah, the particles have this nice motion. Actually, I'm going to change the lifetime here.
Okay.
Just 1 second for now. Make them last for a bit longer. Yeah.
Nice.
So they start to have this ember-like motion, really.
Yeah, you can see them. It looks like they're just dying out, similar to how an ember is.
Exactly. They all now spawn on this plane over here.
Mm-hmm.
So I'm going to add another location offset. Offset. So if I disable all this, you see that all the particles spawn on this plane.
It's strictly two-dimensional at this
Yeah,
point.
exactly. It's strictly two-dimensional. So I want to add a little bit of three dimension to this. So what I'm going to do, I'm going to add location offset. I'm going to enable it again.
Mm-hmm.
And I'll move them up half a meter. So now I just moved the plane up.
Yep.
But like any other feature, this one can also be modified. So I'm going to add this random modifier.
It's like having a volume. Now you're emitting inside of this.
Exactly. Now I am emitting inside of this volume. It's not just a plane. Right. So this volume is created by the combination of these two features: the location circle and the location offset.
Okay.
Right. So now I can add again the cone. So now I'm moving up again.
Now I noticed some of these materials, they're actually turning black when you look upward, which I'm sure many people would experience, correct?
Yes, that's because the sun is up there.
Okay.
So the particles are still are being illuminated by the sun. So when you look down at them, they are being illuminated by the sun. When you look up at them, they are shadowed by the sun.
Okay.
Because we don't really want this effect on these particles, what I can do now is actually add another feature here, the appearance category.
Mm-hmm.
Affects how the particles are supposed to look like, how they are supposed to render, like things like blending and soft intersection. One of them is lighting. So what I can do here is now I have the albedo, the backlight, emissive light, etc. What I'm going to do, I'm going to add 100% backlight. Okay. So that now the particle illumination is now uniform, is isotropic. So they're still being illuminated by the lights in the scene, but uniformly. So they don't care about the direction which the
So,
light comes from. So now they will always look white
okay.
in any direction.
It's a little different than if I was in the material editor and I selected two-sided in the advanced category. I would still be able to render it, but in this case, you're actually even just getting a uniform light on both sides.
That's correct. Yes,
Okay.
exactly. It's really good for this type of effects. There are other effects like smoke effects, which
Mm-hmm.
it doesn't make much sense to do that. You prefer to have just a little bit of backlight. All right, so now let's look at the velocity cone again. So all the particles are having, when they spawn, they have this velocity of 2 meters per second.
Mm-hmm.
Um, let's add a bit of uh, variation to them as well. If I have 50% variation now, not all particles start moving at the same speed.
Yeah.
And also let's add a bit of angle to it, like the random angles. Maybe it's too much. Yeah, it's too much. Just 15 should be enough. Now it goes more like in the cone, instead to go more in this cone shape.
So it's similar to field of view or FOV. All you're doing is you're widening the radius of the near plane or the far plane of the cone.
That's correct. Yes,
Okay.
exactly. So, yeah, that's correct. Right, so now I can add motion physics again. No, the drag is probably a little bit too strong. So what we're going to do, actually, instead of changing drag, I'm actually going to use uniform wind. So I can add some artificial wind to the effect, like 1 meter per second upwards, for example. So now they tend to go more up.
Mm-hmm.
Yeah, so they look like embers now.
And how does this relate to the global wind? Does this actually play into it, or is it just a fake? Because if people are using CryEngine, they know the wind and the detail bending and vegetation. Is it a similar concept specifically on a particle basis, where you have some motion, but it's faked?
So particle effects are affected by the level wind.
Okay.
That's what this attribute is for, the level wind scale. If I set this back to 1, then it's going to be, all the particles are going to be affected by the wind of this level.
Okay, so it actually does interact with
Yeah, exactly.
the levels.
But in my particular case, because I don't really want to interact with the level wind, I just put this at 0, and I add my own wind.
Okay,
It's just as an option.
gotcha.
Or you could combine the level wind with some artificial wind. It's very useful for effects that you want to rise up, for example. Now, what we want to do is we're going to create another component here, another
Another white box.
white box, and going to show another feature. It's called the second generation.
Okay.
So components can be children of other components. So to do that, we're going to create a new second generation on spawn.
Okay.
Now I'm going to connect this to this.
Ooh.
Yeah. So now these white boxes have been connected to our embers.
And they just generate based on the spawn of the first component. So every single place that one of those small boxes that we already calibrated is, it's actually generating one of those white boxes untouched.
Actually can spawn more. So I'm going to show off now. So I go to field size and another modifier here. This time I'm going to use inherit. So now the new particles will inherit the size of the parents.
Mm-hmm.
So instead of using here the spawn rate, what I'm going to do, I'm going to delete it here and I'm going to add a different to spawn distance. So now I'm going to spawn a certain amount of particles the certain amount of child particles based on the speed of the parent. So I'm going to spawn, let's just say, 8 particles
Okay.
per meter. And now, as you can see, now they
Ooh.
start to create this. Yeah, they start to create these trails.
They're like tentacles. Yeah, trails.
Yeah. So I'm going to make these trails a bit smaller. So now lifetime controls the size of these trails. So half a second should be enough. And I actually want more particles. So we have thicker trails.
Nice.
Yeah. Let's also add again the appearance lighting. Right, so now they have this uniform lighting level.
Gotcha.
Right. Now, I don't really want them to look like these separate dots or squares in this case. So instead of rendering them as sprites, what I'm going to do, I'm going to disable this guy, and I'm going to add another type of render. It's called ribbons. Yep. So now these particles are connected. Into these. Actually, now I have to manage them. Yes, half of them is still enough. Yep. And also they are a little bit too big. So the cool thing about inherit, using inherit, is now that I can just change the size of the parent, and all the children will also change their size.
Nice.
So now I can make all the ribbons a little bit smaller. Right. Right. So now as you can notice, yeah, these ribbons they are this kind of like a distorted rectangle. So you can see the ends of them, right? So they're very square. One way to solve that is to go to field size again, add another modifier, another curve, and based on the lifetime of the children, to another shape.
So I guess if you look at this, this is almost like the profile. If you saw it not moving around, it would generate, fatten up, and then skinny up at the end.
Yeah, exactly.
Okay.
Right, so that's exactly what is going on. So now they don't have this square look anymore. Now they actually have, yeah, this bulge and these tails. But now, as you can see, you can still see the parent. So you only want this parent to drive the motion of the ribbons, but you don't actually want to see them. So that's where this icon comes in handy. Because if I just do this, no, I hide the parents, but they still being simulated. They still create new particles, and they still simulate, and they drive the child particles, so the ribbons.
Could you technically create these ribbons without the parent by itself, or is this one of those instances where you do need the parent and the child to create this effect?
The emitter itself, it's a parent. So if you create a ribbon without parent components, this ribbon will always connect to the emitter.
Okay.
There are situations where that can be really useful. So another thing that you probably have noticed is now, because the sparkles are really thin, these tails are really thin. You notice that you see these particles seem to have some aliasing. Now there's actually a really nice trick if you don't want to use anti-aliasing, which is by using this field pixel size. So what this does, it limits the size of the particle to a certain amount of pixels, and instead will reduce its opacity. So in this case, we have 4 pixels. Right? I'm going to actually reduce it to just 2, right? So now the particles will never have less than 2 pixels in size. Instead, it will just fade out. So it looks much smoother without actually having to use anti-aliasing.
I can clearly see that it's a lot smoother. It looks great.
Yeah.
And this is a performance thing. Instead of turning up the anti-aliasing across the entire level, you can just do it on a case-by-case basis.
Exactly. It's very effective to make the particles smoother without having to actually have anti-aliasing, which is a bit more expensive, of course. Now, the particles still look very white, so let's color them a little bit. So let's give some yellow color.
Okay.
So now they look a bit more yellow. But also, like always, I'm going to add a modifier, a color curve modifier.
And I see this curve down here, it's red by default. This is a little different than the other curves, correct?
It's identical. Now the color is actually the RGB color. So there's multiple colors now. There's a red, there's a green, and there's a blue. So what I'm going to do is I'm going to make the blue fade out faster. Keep the red up here probably. And now I'm going to add a bit more orange to this. So it goes from yellow or almost white to orange and then red on the tip. And then yeah. Yeah, it's just, you could spend hours on this. Right, so now there's some color to our ribbons, and then it's just this white, and they start to look more like the cartoonish embers as I was looking for.
It kind of matches the theme of the overall particle effect as it is.
Yes, exactly. Now let me turn these guys on again to see how it looks.
Yeah. It's like I don't know, Mulan or something. Have you seen that movie? It's like a Disney movie where stuff's always on fire, but it's a Chinese-based movie, and it's got this look, these effects and whatnot with the fire.
See, yeah.
It looks pretty cool.
So now I can see that maybe the embers have too much lifetime, so we're going to reduce the lifetime.
It's a blazing inferno.
Yeah, exactly.
The color matches quite well, actually.
Yeah, the color's not bad. Yeah, exactly. It has this yellow. The yellow matches pretty well.
So, do we want to add anything more to this, or is there something else you'd like to show?
Okay, so there's other effects that I like to show that we've been working on. For example, this one here. Some sort of firework effect.
Very nice.
So this effect shows a lot of the many different features that are supported by Wavicle. So look at it here. First, is a very complex effect. Has many components. There's not just second generation, but actually has a third generation.
And so getting into that, the third generation, I guess the first generation is just like we did with the fire, the base emitter, and then the second generation goes up, and then the third generation is this actual explosion that you're seeing in that case.
Right, so in this particular effect, yes, exactly. So the first generation particles are the actual rockets themselves, and these rockets will spawn glitter and smoke, and then and also the explosions. Now, something interesting here is like as you can see, you have three second generation features.
Mm-hmm.
First, you can actually connect each second generation feature to multiple components at the same time. It's not just limited to one component.
Ah, interesting. I
Yeah.
didn't know that.
Right. So, and you have, of course, the on spawn, on death. There's also the on collision. But this one in particular here, is actually really interesting because if you click on it, there's also some settings in here. So usually the default settings is here is in mode is all. That means that when this component triggers
Mm-hmm.
on spawn, it will actually spawn both these components,
Yes.
right? But this one here is instead set to random. So what that means is that even though it's connected to four different components,
Mm-hmm.
it will only trigger one of them.
Okay.
So this is what is being used to create these different effects. So some rockets will create these blue effects. Other rockets will create this, I think, this willow kind of effect. I think that's the name.
Mm-hmm.
Or some crackers. So all of these effects are these components. So this one and this one down here, and the rocket will randomly trigger between. Randomly trigger one of them.
It's pretty modular. I mean, I get from first glance, I thought that you would have just set up a specific type of rocket that went up on each node tree.
No, the rocket is always the same component.
Nice.
It's the rocket itself that then decides to randomly pick the other effects.
Okay.
We mentioned earlier about the GPU particles. So all of these particles are CPU. Everything that we've seen was done in the CPU, except for this particular effect here. I think it's this one. Yeah. So as you can see, this one uses instead of GPU particle sprites.
Mm-hmm.
So this is this blue thing. So these are actually GPU particles. So these blue effects are being simulated, fully simulated on the GPU. And as you can see, they're actually individual dots.
Ooh.
They're not ribbons. They're actually separate dots.
Nice.
And each one of these dots is being simulated.
And I guess the hit is not too extreme on this. Like, how many particles do you think are actually being generated on the GPU particles? Does it say? Do we have? I think I saw the max particles.
It's maximum number of particles 100,000. No, maximum number of particles is 130,000 particles. In this
That's quite a few.
Yeah, it's quite a few.
Fair bit. How high? What's the highest amount you've ever actually simulated?
Around 2 million.
Ooh, not too bad.
Yeah, the modern GPUs can handle. Depends also what the scene is doing, but modern GPUs can actually handle a lot of particles. CPUs can also handle a lot of particles now. Even if I disable this the GPU particles, we're still probably talking about 80,000 particles for a CPU.
That's not bad.
Yeah. Another thing that it shows off also is each rocket actually has a light.
Mm-hmm.
Well, it is during the day, so it's a bit hard to see, but you can see that the lights are affecting the smoke.
Maybe we could actually change the timing to. Oh, lost me. Oh, nice! I can already see the light.
Actually, it looks way better during the night.
Yeah,
surprisingly,
that's pretty good. Nice.
Yeah. Another effect that I also like to work on is this type of effects, lightning effects.
Ooh. Yeah. I see it. It's like a versus game where you're doing a move on somebody, and it's like, yeah, I'm just gonna electrocute you.
Exactly. So this one shows a few other features that we have in Wavicle. There's also multiple components here, and another feature that we have in this second generation is the probability. Actually, this one. So not only can choose randomly between shard components, you can actually add the probability of it triggering at all.
Nice.
So in this case, we are using this probability to branch off. So if I remove the probability, this is what happens, right? So
Whew.
yeah, so every single
It's like a nervous system.
yeah, exactly. So so if I solve it, so every single segment of this ribbon will
Mhm.
trigger a branch.
Okay. Ooh.
Yeah, but if I add back the probability, only a few will actually trigger the branch. So it looks more like and less like a branch.
Yeah, I mean that was quite intense though.
Exactly. Yeah, this also uses this cool feature, the location being. Also, as you can see, this component here is a combination of multiple location features.
Mhm.
Let me put it down here. So you have the beam, which actually creates the beam.
Mhm.
It creates all the particles in line. And then there's a few series of offsets with some modifications, and then there's also this noise. So if I solve this again, so we start just with the single beam,
Ah, I see. This makes a little bit more sense.
right? Oh, this motion that you see here is also, I think, is created by the field size. Yeah, exactly. That motion is actually this curve.
Oh, okay.
It's modifying the size of the actual beam.
So it is actually size. You,
Yeah,
when you look
exactly.
at it, you think it's just like the emission or the emissive intensity of light.
No, in this case it's actually size, because here the appearance lighting it actually has a really intense soft emission,
Nice.
right? And then by using here the pixel size,
Mhm.
which then reduces the opacity, you actually opacity also has the effect of reducing the soft emission.
Okay.
So and then with the mix up and then mix up with glow,
Okay.
it gets this motion type effect. So and then on top of the beam, add other location features.
It starts randomizing it.
Yeah, start to randomize, and then there's also this noise feature to create a bit more.
Pretty realistic.
Yeah.
So I think this covers a lot of the today's particle showcase.
Exactly.
And I'd like to thank you for giving your presentation and showing everybody exactly how to use the system.
Yeah. Thanks for having me.
And I look forward to more videos.
Yeah.